Okay, today's lesson's looking at scatter plots again, but this time we're looking at the interpretation of scatter plots. So one of the key things we looked at last time was looking at the relationship or the correlation within a scatter plot. So we've talked about already that scatter plots are used to show the relationship between two sets of data. So here we've got three graphs. We've got the relationship between shoe size and height. We've got temperature and soup sales, and the last one is annual income and shoe size. So when we talk about relationships, there is either a positive correlation, which is as one quantity increase, so does the other. We have a negative correlation, as one quantity increases, the other decreases. And thirdly, the last one is looking at no correlation at all. Both quantities vary with no clear relationship. Now, without actually looking at any other sort of measures, we can use our common sense and work out that this third one is the one where there is no relationship, which is what we would expect with your shoe size and your annual income. Your annual income doesn't affect what shoe size shoes you get, your genes do, and likewise the other way, it doesn't affect either. The other things, looking at shoe size and height. So this one, if I put my line of best fit in, I can see as the shoe size increases, the person's height increases. So the key thing is it makes sense that people with bigger shoes are taller. And likewise, it makes sense that there are no points in this area or this area. This would mean someone with a really large foot is quite short. This point here or this area here would be a really small shoe size but really tall. So that's a positive correlation. Temperature and soup sales. As the temperature increases, the soup sales decrease, which makes sense. People are less likely to buy soup if the temperature goes up. And likewise, if the temperature is low, there'll be more sales of soup. So that's a negative correlation. And the last one we've already talked about being the shoe size and the annual income. The other thing to look at with no correlation, if I did put a line of best fit in, it could equally fit there or there. It would make no difference. It doesn't really fit the pattern that we have here. We have points in all four corners of our graph. Here you can see there is no points out here, there's no points out there, and like we've said before. So it kind of makes sense that those lines would fit there. And that's emphasizing that as well. So here we go at 6 different sets of data, each with 2 variables. Take a moment to write down in all 6 what type of correlation, so whether it is positive, negative, or no correlation. I'll get you to pause the video now and complete that for those 6 questions. Okay, well done giving that a go. So question 1, math scores and physics scores. Obviously it's a positive correlation. And that makes sense that physics and maths are aligned relatively well. If you are strong at maths and you're able to answer maths questions, there's a better chance that you'll be able to answer physics questions. So they're kind of related. Car engine size and petrol consumption. So this is negative. As the engine sizes increase, they use more petrol, so less MPG or miles per gallon. Next one, key stage 3 results. So this is a UK slide. So that's a test that's taken in when you are 13 in the UK. So the relationship between that and height is obviously none. There's no relationship. Your height doesn't affect how well you do in that exam, and how well you do in your exam doesn't suddenly change your height. So question 4 is negative, the outside temperature and the heating bill. If the temperature is up, it means the heating bill will be less, so that makes sense. Number 5, sunshine hours and sales of sunscreen. More sunshine, more sunscreen, so positive. And number 6, the age of the car and the value of the car. The older the car, the lower the price, so negative. So well done if you got all 6 right. If not, go back and see if you can use your reasoning to predict that. So what do we look for in a scatter plot? So we've talked about some of these things already. Obviously the relationship, whether it's positive or negative. The next one's looking at scatter. So do we see a strong relationship where there is little scatter or a weak relationship? We talked in the previous lesson about that there's a middle ground which is moderate, but that tends to be subjective compared to when you're looking at a graph on its own. Really needs to be compared to other things. The other thing is you could be looking at constant scatter or a fan or a funnel in non-constant scatter. So here we end up with values that fit a pattern all the way along. There's an even spread. Here in this graph you can see it's quite tightly, that there's less scatter at the bottom, but as it goes out, it fans out like this. So that's a fan, and it kind of makes sense that if it goes the other way for a negative or positive, so tightly packed at the end but starts off very scattered. So you could describe graphs like that. What that means is that the relationship is stronger at different values of the one of the variables. So here is a task I want you to complete. If I label these A, B, C, and D, I want you to rank them in strength from strongest with 4 and weakest with 1. So pause the video, just write the numbers down and see how you get on. Okay, so well done giving that a go. I think I gave away the first one that B was the strongest, which is pretty obvious. There's a nicely packed line that goes between them. So then for the next strongest to give the 3, okay, well, gone with D. And then for 1 and 2, the weakest and the other one, and the next the strongest after that, for the 1 and the 2, for A and C, I can understand if people go either way. But I went with 2 for A and 1 for C, and they're certainly both weak. But I would say that 1 is weaker because if I put a line of best fit in A, there kinda is a line there, whereas with C, I could put a line there, I could put a line there, I could put a line there or there, and it would be it'd be equally look the same. So how did you make your decisions? The less scatter there is about the trend line, the stronger the relationship is. So you can see these ones that we chose. So there's a clear pattern there. The other two, you could argue either way. So other things we look for in a scatter plot is we look at outliers. So a key thing that we need to think about with outliers is this value here, is that it must be away from the trend. It's quite common in scatter plots that people talk about They might talk about points that look like this, and then they see a point way out here and they say that's an outlier. But it's not really, because it still fits that pattern. An outlier has to be in this region away from the line way out there. So just be really careful about talking about outliers. It must be away from the pattern that you see. The other one, of course, is looking at groupings, and there could be a reason for those gaps. So that's an interesting one as well, is that if we take a look at our patterns, if we take a look at our patterns, it kind of fits even though there's a gap. It might be that we just didn't test people within that range is the reason for the gap. So generally with groupings and anything unusual, they require further investigation. You need to find more information. So what we're going to have a go at is that I've got 6 sets of data here looking at mother's age and their baby's birth weight. I've got open road fuel consumption with cars. I've got rugby players' weight and height. I've got marathon runners' time and their stride length. I've got sharks' fork length and total length. So the fork length is the length between the top of their tail to the bottom of their tail. And the last one is the weight of a car and their fuel consumption. We're going to go through the process of looking at all these features. So first of all, whether something is positive or not, positive or negative. Next thing, the strength, the scatter, the grouping, and anything unusual. So if we take a look at the mother's age and the birth weight, so is it positive or negative? Okay, so we've got this problem here that there's no real association at all. I couldn't put a line of best fit for that graph at all. So because there's no relationship, there's no strength. The data is scattered because there's no relationship. It appears that the grouping is 1, and the only thing that's unusual is looking at these points here and here, where we've got a mother's age of 28, but they've got a small baby, and an older mother who has a particularly large baby. But because there's no pattern or relationship, it's hard to talk about those points with any detail. And this is the process that you need to go through of analysing and looking for features in a scatter plot. So here we've got another one. So looking at the open road one, so whether it's positive or negative, I think it's clear to see that that would be negative, putting a line of best fit in. Looking at our rugby players' weight and height, we can see that that trends upwards from left to right, so that would be positive. Looking at our marathon runners, that's quite clearly that it's a negative, so it's trending downwards from left to right. The fork length and the total length of the shark, we're trending upwards there, so that's positive. And the weight and the fuel consumption, we can see that that's trending downwards. Going back to the strength, obviously with our mother's age and birth weight, because there's no relationship, we say that it's there isn't any strength. If we look at the engine size in the open road, we're quite comfortable that's moderate, so there is quite a bit of scatter. The rugby players' weight and height, again, quite scattered, so we say it's weak. Marathon time and stride length, we'll go with strong. There's very little scatter between those. The fork length, that's very strong in strength, a positive association. And the last one, the weight of the fuel consumption, we can say that that's moderate in strength. So after strength, we then look at the scatter. So the data is scattered for the first one. It's all over the place. The second one is that the scatter seems fairly even all the way along. Looking at the rugby players again, it seems uneven. It's quite scattered up at this end, and it's not so scattered down here. Looking at the marathon, it seems evenly scattered. Obviously, there's very little scatter in the shark fork length and total length. And the fuel consumption, number 6, we can see that there is scatter and it seems to be even. Groupings. So obviously the mothers grouping, there's one big group. For the engine size and open road, there appears to be 2 different groups. So that could be there and there. And you'll notice that's around the under 2 litres. So less than 2 litres. And this is more than 2 litres. Which, if you know a little bit about buying cars, that tends to be a bit of a cut-off point between the economy cars and bigger trucks and utes and things like that. So for number 3, the rugby players, it appears to be in 2 groups. That might suggest a difference. So there seems to be a group there and a group here. It may be that that's because there's a difference between forwards and backs. The marathon runners appears to be one long group and big group. The sharks, there appears to be one grouping there and another grouping there. Now what we have to be careful of is that we just haven't found the sharks that fit in between that length. It might be that we have 2 species of sharks that we're comparing. So that needs further investigation. Here there appears to be just one big group. However, this here we wouldn't class as an outlier because it kind of fits the same pattern. For a point to be an outlier, we would expect it to be in this region. So the last one is looking at outliers. We've talked about the first one already with the 2 points up the top and the bottom. Talking about the engine size. At 1 litre out here, again, it's within the same pattern, so it's harsh to say that it is an outlier. Again, but more investigation is needed. With 3, there appears to be an outlier at 84, which is away from the main grouping. More investigation is needed. With the marathon, there doesn't appear to be too many outliers, that they stick to the main pattern. And the fork length and total length of the shark, there appears to be no outliers. And the last one is that there doesn't appear to be any outliers. We've just got to be careful about that point up the top there. So then once we've done all that and we use all that information, we find all that information, we've then got to use it to interpret the regression line or the line of best fit. And what we say is we have to describe with the variables what it means. So with the first one, there is no relationship between the mother's age. There is no relationship, and a mother's age is not a reliable way of predicting a baby's birth weight. Here, the engine size and open road. The relationship is as the engine size in litres of a car increases, the fuel consumption decreases. That's that negative relationship. Rugby players relationship is as the weight of a rugby player increases, so does their height. Marathon times, the relationship is as the marathon runner in minutes. The relationship as the marathon time in minutes of a runner increases, their stride length decreases. With the sharks, the relationship is as the fork length fork length in centimeters of a shark increases, so does their total length. And the last one, the relationship is as the weight of a car increases, the fuel consumption decreases. So the key thing is to relate those two variables together. Now you'll notice how this is color coded, that the one on the bottom is the red variable, and this one is the blue variable. Oh, sorry, the purple variable. It's really important to keep that order the right way around. And also you can notice that all the black words, the black letters and phrases are generic. You can just relate it to your context. So the key thing is to find the relationship, whether it's positive or negative, and if, depending on that, and any other features you can find, depending on that, interpret the regression line. There's a task on your OneNote, complete that.